All right, so let's move forward then. Okay, so first step, abstract syntax. By now this gets formulaic. So we have abstract syntax in our language. So we still have our favorite expression, which is going to be const. You're going to have your ident. You're going to have all your arithmetic, booleans, comparisons. Okay, so you're going to have comparisons, if then else, your usual stuff. Let bindings. So all of that. Functions, recursion, the let rec binding from last week. And now comes the new stuff. So we're going to have a new ref of an expression, which is a single argument. Then comes the dereferencing. So this is going to be deref of an expression. And last comes the assignment operator, assign ref of an expression. All right. So 3 new constructs in a language where there is a ton of new constructs, right? So there's at least 5 or 6 new constructs we have studied, and now we are adding these 3 extra things. How difficult can it be? All right, is this okay? So should I write and program in, I made a mistake, didn't I? Assign ref should have 2 arguments. You're assigning the pointer to the pointer, the whatever value I would like to assign. Thank you. Thank you. Thank you, Timophone. Everyone okay? All right. Okay, so let us start with how do we do the semantics, and let's start with the big problem that this language now has that the previous language did not have. The previous language has a name until this part. This language, until last week, has a name. It's called a pure functional language. Or you say it's a language with no side effects. Okay. All right. So it's like the homeopathic medicine of languages, no side effects. All right. The point is, what is it? What is a side effect? So let's talk about this cool concept called a side effect. What is a side effect? Okay. So a side effect, it's like in medicine, right? You take a medication which is supposed to cure your headache, and let's say suddenly all your nails fall off. Oh, no. Okay, fine. But that would be a scary example of a side effect, right? In programming languages, side effects are meant to connotate the same thing, right? A side effect is like you carry out some computation, and as a result of the computation, something else happens. Okay, so Jarek has a really good definition. Function handle everything without reassigning anything, so everything is self-contained and easier to debug. Another way of saying the same thing is, let's think about the notion of a pure function. A pure function is a function where if you give it the same input, you get the same output. You would be like, isn't that the definition of a function from 2824? Yes, that is the definition of a function, and that's called a pure function in programming languages. What else can be there? Well, there can be functions that are impure functions. Like as an example, you can write a program where you can, in C, C++, Python, Scala, you can write a function. You can write a function that returns a random, let's say it takes the number. So it takes a number as an input, and it returns a number. And it simply returns a random integer with seed. So let's say it just returns a random integer. That's the behavior of the function. So the function fn is simply taking in an argument and returning a random integer. Mathematically, as a mathematician, you would say this is not a function, because if I gave it the argument 10 once, then it might return the random number 1 0 1 2 1 1 2 3 4 7. If I gave it the argument 10 again, the next time around it might return 7 2 9 1 7 2 4 3 1 2, something like that. So the point is, you can have the same input, and two different times you can have two different outputs. Okay, and this is an example of what is called an impure function, or sometimes you call it a function with a side effect. Can you give me other examples of how you could create impure functions? Can we look at other examples of impure functions? Either in Scala or any language. Functions with global variables, like anything that has a scope outside the function. In fact, John, you don't even need global variables. If you could have your function inside a class, and once your function is inside the class, you could increment a counter every time you call the function, and you could return the value of the counter. You don't even need a global variable, right? A function that uses external time, for example, look at the time of the day and return n times the time of the day, that would be an example of an impure function. What other kinds of functions could have side effects? How about functions that take an input from the user? Oh, shared memory, multiple threads. Wow, you guys are like really, really complicated here. Sure, but simple things like asking the user for an input, like anytime you call the function, ask the user, what should I return, right? You can do that, right? So there is a lot of ways of creating side effects, right? In fact, side effects are really, really common. If you had side memory, what's called static memory, you could use that. If you had global variables, you could return the time of the day. You could count the number of network packets that were received in the last 5 seconds and return that, right? So a lot of things can go on that cause things like side effect. So then what's a side effect? Well, a side effect is any computation other than the computation that needs, that returns a value. Any computation that stores information on the side is called a side effect. It's not a well-defined term. I mean, you usually know what you mean when someone says that's a side effect, but it's like looking at many different things and trying to cram it into like one single terminology. Printing something is an example of a side effect. So there is a lot of what goes on as side effects. There can be a lot. Okay. So far in Lattice, the language did not have side effect. Okay, so the language did not have side effect. But now the language is going to have side effects. All right, so now the language is going to have side effect. And in fact, previously, the language had something very interesting. It had something called referential transparency. What does referential transparency mean? So let me give you an example of what a referential transparency means. So as an example, suppose I had a big program, and inside that program, I had an expression, like a complicated expression, and I knew that this expression always evaluates the value 10. Okay, so I have a big program. Inside that program lies a complicated little expression. Let's say this expression is like 2 times 5 plus 1 minus 1 times, okay. So there's a lot of complicated stuff you're doing. And let's say inside that program, there is going to be an expression. So Logan has a question. Is it like public access in Java? Not quite. But let me explain what referential transparency is. It doesn't have to do anything with like people outside being able to see it or something like that. But let me give you an example of what referential transparency is. Okay. So suppose I took a program and I had an expression in the program, somewhere embedded in the program, but let's say it just evaluates to 10 every time. So suppose I took away that complicated expression and I just replaced it by the value 10. Where it used to be, I just replaced it by the value 10. Should the execution or should the final return value of the program change? So let me repeat my question. I had a complicated expression, something like this, and let's say it just always evaluates to 10. So I just replace it by 10. What's a complicated way of writing 10 in letters? For example, you could say let x equals 5 in let foo equals um, you know function of z in z plus x in foo of 5. So this is a complicated little expression. And let's say it was somewhere inside a program, and you look at it and say, hey, this is just 10. Is that okay? So you look at it and you say, this is just 10. So I'm going to replace it by 10 and save a bunch of computation in that process. So let us imagine a huge lettuce program with all kinds of let bindings. And this is as of last week. As of last week. Will the value of the entire program change if you took this sub program out and swapped in 10? Do you think it will change? No, right? It doesn't seem like it should change. But today with new ref and assigned ref, I guarantee that you can easily write a program which is going to break referential transparency. So until last week, our lettuce language enjoyed referential transparency. Today, it is not going to enjoy referential transparency. Can you give me an example of an expression which computes a value 10, but is not going to be referentially transparent? So could we come up with an example today using assigned ref and new ref that's not going to be referential transparent? So obviously we have to somehow involve references, right? So let's do an example. Let's do an example that has the same value 10. Okay. So let's do this. So let's say here's the simplest example I can come up with, right? That's not referentially transparent. Okay. So it takes in a reference and changes the item stored. So Kai has an idea. That's an excellent idea, right? That wouldn't be referentially transparent. Or you could do something like this. Just create a new cell in the memory. So let x equals 5 in, let z equals new ref of x plus 5 in, let's say, dref of z. So this whole thing, this whole snippet does give you the value 10. But it has something else going on. Every time you tackle this snippet, you do create a new cell in the memory and you put the value 10 in that cell. So this does have the side effect of creating a new cell in the memory and putting the value 10. Another example could be like this. So let us take another example. Let x equals new ref of 45 in, and let's take this portion of the program. Let z equals 25 in. Okay. So let z equal, let me do it properly. So let x equals new ref 45 in, let z equals, and then here I'm going to say let y equals assigned ref of x 10 in y in, let's say dref of x. So this is Kai's idea. So here, look at the snippet that I have shown in blue. What is this snippet by itself? What does it evaluate to? What's the value of the snippet? So y is going to get the value 10. Do you agree? Because I am assigning 10 to x. So this entire snippet is 10. So in the interest of referential transparency, if I replace this snippet by 10, is the program going to be the same? No, right? It's going to completely change the value of the program. Is that okay? So unfortunately, we break referential transparency. And because of that, we need to pay for it. How do we pay for it? Well, we are going to pay for it in the way we have to handle the interpreter, or the way we have to do the interpreter is now has to completely change. because we no longer have referential transparency. So certain things which we were, how to put it, very lax earlier are now going to come and bite us in the back. So we better not start being so lax today. All right. So what are these things? So before we go there, where am I right now? So I have defined a language. I gave you the informal idea. I gave you the abstract syntax tree of that language. All right. I have gone that far. And we talked about some problems, issues, side effects. And we talked about referential transparency, a very important concept, right? We talked about all of that.